Maimuna, am I audible to you? Jasola, am I audible to you?
Yes, sir.
Oh. Wait 5 minutes. Let's start with the dual nature of light. Fine. Now, dual nature of light. Dual nature of light means light has two nature, particle nature and wave nature. Fine. So light have the properties of electromagnetic waves, means the properties, the phenomena like interference, polarization, diffraction. These can be explained on the basis of wave nature of light. Whereas the phenomena like photoelectric effect, Camphatan effect, and these effects can be explained on the basis of particle nature of light. Now, according to Einstein, actually Einstein used the Planck's quantum theory. Planck's quantum theory means the light is made up of discrete packets of energy known as quanta. Fine. So Einstein used Planck's quantum theory. According to light consists of packets of energy, and these packet of energy is known as quanta, and each packet of energy is called photon or quantum of light. Fine. These packets travel in a straight line with the speed of light. Further, electron emission. Electron emission means the emission of electrons from the metal surface known as electron emission. There are 4 types of emission. Thermionic emission means by heating the metal, means let it be a metal, how much heat, let it be X amount of heat is transferred to the given metal to escape out the electrons from the metal surface. That kind of emission is known as thermionic emission, and the electrons which are generated while emission are known as thermions. Field emissions, you have to put the metal under the high electric field. So what happens? So if you place a metal between high electric field, now as we know that the metal contains free electrons, and these electrons experience a force due to the electric field. So due to this electric force, the electrons will escape out from the metal surface. That kind of emission is known as field emission. Secondary emission means by the bombarding of high speed electron. Means let it be a metal surface, let it be every metal surface consists of n number of free electrons. Let it be this electron moving with the velocity v. It has high kinetic energy, and this electron will collide with this electron, and this will transfer the entire kinetic energy to this. Let all of them come, then we will start. Anita. Alan hasn't come. Start with emission. Okay. Emission means the emission of emission means the escape out of the electrons from the metal surface is known as emission. There are 4 types of emission: thermionic emission, field emission, secondary emission, and photoelectric emission. Thermionic emission means you have to place the metal surface under the high temperature so that the electrons will be able to gain sufficient amount of heat energy to escape out from the metal surface. This kind of emission is known as thermionic emission. Field emission means you have to place the metal surface within the high electric field so that due to the electric field, the free electrons of the metal surface will experience high electric force so that they will escape out from the metal surface. This kind of emission is known as field emission. Secondary emission means let it be a metal surface. A high means let it be an electron having high kinetic energy, and this electron will collide with the free electron of the metal surface, so in such a way that it transfers the entire energy to the given free electron, and the free electron will gain the kinetic energy or the velocity from the colliding electron, and it escapes out from the metal surface. This kind of emission known as secondary emission, high speed electron. Photoelectric emission means by falling of light of the suitable frequency. When this light falls on the given metal surface of suitable frequency, so the free electrons of the metal surface gain energy and they escape out from the metal surface. This kind of emission known as photoelectric emission. Is it clear till here?
Yes.
Now, work function. Basic definition. This chapter is much easier than the other chapters. Work function, the minimum amount of energy gained by an electron to escape out from the metal surface. That is known as work function. Work function is a energy. It is denoted either by phi or W naught. What electron volt? So what do you mean by electron volt? Electron volt, let it be two plates having positive and negative. Let it be the potential is 1 volt. Fine. If you place, so everyone knows there is a potential difference. The distance between the plate is d. So there must be an electric field between the plates. And if you place any electron within the plate, so definitely this electron will experience an electric force. So due to the force, it will accelerate, and due to the acceleration, it will gain some velocity. And if it gains the velocity, there must be a kinetic energy. So the kinetic energy, so the kinetic energy gained by an electron when you place within the plate having potential difference 1 volt, that energy is known as 1 electron volt. All right. So the energy gained by an electron when placed between the plates having potential difference 1 volt, that energy is known as 1 electron volt. Is it fine till here? Is it okay till here? Or shall I repeat? So the amount of energy gained by an electron having potential difference 1 volt is known as 1 electron volts. So 1 electron volt equals to 1.6 × 10⁻19 joule. So work done equals to change in kinetic energy, and work done is also equals to, as I told you in electrostatics, Q times potential, and Q, what is Q? Charge on electron is 1.6 × 10⁻19 coulombs into potential is 1 volt. So if you multiply, you will get 19 joules. 1.6 × 10⁻19 joules. So this is work done. Work done equals to kinetic energy. So 1 electron volt equals to 1.6 × 10⁻19 joules. The chapter is very easy. Now, photoelectric effect. Basically, photoelectric effect completely based on the particle nature of the light. Fine. So, photoelectric effect means the emission of electrons from the metal surface when a radiation of suitable frequency falls on the given metal surface. Means radiation means the light. When the light of suitable frequency falls on the metal surface, so electrons gain some energy from that radiation, and they escape out from the metal surface. That phenomenon is known as photoelectric effect, and the emitted electrons are known as photoelectrons, and the current produced while emission is known as photoelectric current. And this is radiation in metal surface. As the radiation falls on the metal surface, so the free electrons of the metal surface, they gain some energy from the radiation and they escape out from the metal surface. These are known as photoelectrons. Effect of intensity. There is an experiment conducted in which it is found experimentally that if we increase the intensity, the number of photons increases, and if the number of photons increases, the photoelectric current increases. So intensity, photoelectric current is directly proportional to the intensity. Remember one thing. Fine. So if we increase the intensity, photoelectric current increases automatically. Linearly, the relation is linear. And just remember this, intensity is directly proportional to photocurrent, is directly proportional to number of photoelectrons emitted per second, is proportional to the distance square. It means if we increase the distance of the source from the sensitive metal plate, then the intensity decreases, hence the photoelectric current also decreases because the number of photoelectrons emitted per second decreases. The effect of potential on photoelectric current. Effect of potential. Now, it is found experimentally. Just remember this graph. This is stopping potential. First of all, there are two parameters. First is stopping potential, second is saturation current. So saturation current means the maximum current in the circuit. Fine. So the maximum current in the circuit is known as saturation current, and stopping potential, the minimum negative potential at which the current in the circuit becomes zero. That potential is known as stopping potential, retarding potential, cutoff potential. Fine. So saturation current is the maximum current in the circuit, whereas stopping potential is the minimum negative potential at which the current in the circuit becomes zero. So this is collector plate. There are two plates. Is retarding potential. Now these are the intensities. Fine. If we increase the intensity, then the current increases linearly. Fine. Now just remember one thing. The stopping potential completely depends on the frequency. Fine. So stopping potential depends on the frequency. Fine. So stopping potential depends on the frequency, and current depends on intensity. This is the graph. Now saturation current, the maximum current in the circuit. cutoff or stopping potential, retarding potential, the minimum negative potential for which the current is 0. Now remember this thing. This is a relation. These are two plates. Let it be an electron between the two plates. Fine. Let it be an electron, which is stubborn. Fine. So this electron means, when do we say the current is 0? When there is no flow of electron. Fine. So let it be an electron which is complete, means which is stubborn, and this electron is trying to approach the second plate. Fine. If this current, so we have to do some extra work then to stop this electron. So the work done equals to change in kinetic energy. So work done equals to change in kinetic energy. So let it be K max. We have to do some extra work done to stop this electron. So work done equals to, in electrostatic, Q times V, and this is an electron. So charge in electron is E, and V is the stopping potential. That is equals to half mv square. So this amount of work we have to do to stop that electron, so that the current in the circuit becomes 0. This relation you have to remember it. Now, effect of frequency of incident radiation. Sorry. The effect of frequency of incident radiation is stopping potential. These are stopping potential. If we increase the frequency, it means if we change the light, so frequency will vary. So if we change the frequency, the stopping potential will change, keeping the stopping potential, keeping the saturation current constant. Fine. Because in all the frequency, means let it be 3 lights, blue, green, or yellow. Fine. So frequency will change. And if we keep the intensity same, so saturation current will be same, because it completely depends on the intensity of the light. So if we change the frequency, the stopping potential will change, but current will not change, because it completely depends on the intensity of the light. So these are the stopping potentials, negative. Fine. Just remember one thing. If we increase the frequency, then the stopping potential will increase. So nu3 means, let it be the third light frequency. This light has highest frequency, so stopping potential will be high. Likewise, nu2 is greater than nu1, so stopping potential for this light will be greater than the first light. Fine. So there are 3 lights have frequency nu3, nu2, and nu1. So which will have the higher frequency, that will have the higher potential, stopping potential. So stopping potential depends on the frequency. And just remember one thing. So as stopping potential, this is stopping potential. Fine. This stopping potential completely depends on the frequency, and this kinetic energy also depends on the stopping potential. Hence, the kinetic energy is linearly depend on frequency. Remember this thing. Kinetic energy linearly depends on frequency. So stopping potential depends on the frequency, and kinetic energy also depends on the frequency, but the current depends on the intensity of the light. And the relation.
Does it mean that when if frequency is higher, stopping potential will also be high?
Yes.
Okay.
Now, stopping potential with the frequency of the graph, these are two matters. Fine. So this is a graph. This is nu naught. This is known as threshold frequency. The minimum frequency required to escape out the electrons from the matter surface, that is known as threshold frequency. So what is threshold? Threshold. Sorry. Right. Right. Threshold means the starting. And actual, according to the vocabulary, threshold means the starting. So the minimum energy. So the minimum frequency, or the minimum frequency required to escape out an electron from the matter surface is known as threshold frequency. These are the threshold frequency. And below threshold frequency, the electron is not able to escape out from the matter surface. The slopes are parallel. Now try this question. The chapter is very simple. Now try this question. 2 minutes and write your answer in the chat box. Alan, am I audible to you? Aksha, everyone?
Yes.
Farhad didn't come today. Sorry, she hasn't come to. Do and write your answer in chat box. And write your answer in chat box. Fast. Write your answer, everyone in chat box. Have speed up. The figure shows a plot photocurrent versus anode potential for a photosensitive surface for the three different radiations. Which of the following is a correct statement? Curve A and B represent the incident radiation of different frequencies and different intensities. Curve A and B represent the incident radiations of same frequency but of different intensities. Rest of you, write your answer in chat box. Speed up. B. Now B is the correct answer. Because the stopping potential is same, hence the frequency will be same. B is the answer. Try this question fast. A photocell employs the photoelectric effect to convert. Photocell is an instrument, it based on the particle nature of light. Fast, write your answer in chat box. Everyone, Saifullah, Aksha, Hanifa, Hiba. Fast, write your answer in chat box. Everyone, please write your answer in chat box. Speed up. जाओ तुम. Answer is B. B. So the photocell employs the change in the intensity of illumination into a change in the photoelectric current. Try this question fast. This one, try. Everyone write your answer in chat box. Which of the following is correct? The storming potential increases with the increasing the intensity. This photoelectric current increases with the increase of intensity. The current in photocell increases with the increasing the frequency. Which of the option is correct? Write your answer in chat box. Speed up. Maimuna, write your answer. Hiba, Aksha. Done. Which is the correct option? C. Look, the photocurrent increases with increasing the intensity. The photocurrent increases with increasing the intensity. Till here, is everything okay? Alan, if I increase the frequency, what is the relation between frequency and intensity?
That's directly proportional.
Okay. Look, just let me know one. Okay, just one thing. This is current, that will be photocurrent. If I plot the graph between current and frequency of incident light, so will it be like this? All this. Which of the graph is correct? This is A and this is B. All
So
of you
A.
write, all of you write your answer. The relation between the current and the frequency. This is A. Rest of you write your answer. The relation between current and the frequency. Look, why A? Current doesn't depend on the frequency, all right? It is independent of the frequency. So B is the correct option. Fine. So B is the correct option. Directly proportional when current and intensity graph. If I increase the frequency, potential will, Alan, potential will increase or the current will increase if I increase the intensity?
So asset potential.
Stopping potential. What is saturation current, Mamuna?
Like the temperature is at
Saturation current. The maximum current in the circuit. All right. Saifullah, what is stopping potential?
The minimum potential to
The
stop an
minimum,
electron.
yeah, the minimum negative potential at which the current becomes zero. Okay. Kinetic energy depends on frequency or the intensity, Alan. Kinetic energy depends on which factor, frequency or intensity?
So asset frequency. Not sure.
Frequency. Hiba, am I audible to you? Aksha, what is saturation current? Hiba, what is saturation current? Hiba, am I audible to you? What is saturation current? Shaifullah, what is saturation current?
The maximum current in circuit.
The maximum current in the circuit. Now, Einstein equation. Fine. So photoelectric depends on the particle nature of the light. Just remember one thing. Fine. So light has dual nature, particle nature and wave nature. Wave nature means if we have to explain the phenomena like interference, diffraction, So these phenomena can be explained on the basis of wave nature, whereas if we have to explain the particle nature, if we have to explain the photoelectric effect, then we have to treat light as a particle, means a discrete packet of energies, that is known as photon or quantum. Now Einstein equation, this is, let it be, this is a metal surface. As the light falls on this metal surface, so let it be, this is the electron. This photons, as this photon strikes the electron of the metal surface, so this electron will gain the energy from the photon. So some amount of energy will be used, some amount of energy will be used in liberating the electron, and the rest of the energy will be converted into the kinetic energy of the electron. So according to the conservation of energy, so this is the photon energy, this is the photon energy. Energy of a photon equals to h nu, where h is the Planck's constant and nu is the frequency. So this energy is distributed in two parts. First is the work function, that means work function means the minimum energy required to liberate an electron from the metal surface, and the rest of the energy will be converted into kinetic energy, that is half m v max square, half m v max square. Now if you further simplify this equation, so if I move work function here, just remember one thing, work function is also s times nu naught. Nu naught is the threshold frequency. So h max equals to, sorry, half m v max square equals to h nu minus phi naught, and phi naught we can write h nu naught, and we can take out h as common, so nu minus nu naught. So this is kinetic energy, maximum kinetic energy, h nu minus nu naught. And remember one thing, if you we can replace kinetic energy by ev naught. Last time we just maximum kinetic energy equals to ev naught, where v naught is the stopping potential, and we can write this equation in this manner too. Just remember, this is the first formula, let it be first formula, this is second formula. Fine, two formulas. So this is called Einstein equation, photoelectric equation. And just remember this formula, because we will be using this formula while solving the numericals. Now the work function is given. Now try this question. You have 3 minutes and write your answer in chat box. Speed up, everyone. The question is not too difficult, very easy question. The work function is given in electron volts. Write your answer in chat box, everyone, fast. Done. Alan, Saifullah, Aksha, Mamuna. Eva, write your Aksha, Saifullah. Write your answer. Am I audible to everyone?
Yes, sir.
Now what happened? Now the work function is given. Phi naught is given. Phi naught is 4 electron volt. The longest wavelength we have to calculate that can cause a photo emission from the substance. Lambda we have to calculate. Now very easy. Phi naught equals to SC over lambda. Now what is H? What is H? 6.63 10 to the minus 34. Use it and solve for me at least. Speed of light 3 into 10 to the power 8. First of all, we have to change electron volt into joules. Fast. Everyone fast, please. Three. Let me. Now, what is 5? 4 into 1.6 into 10 to the minus 19. What is that? 6.63 10 to the minus 34 into what is C? Lambda. Now try. How much if you solve it? How much will you get if you solve it?
Three 310 nanometer.
$310 nanometer. Yeah, this is the correct one. Mamunad, will you be able to solve it? Saifullah, rest of you.
Yes, sir.
Okay, if you solve it, you will get 310 nanometers. Now try this question. Photons with the energy 5 electron volt. 5 electron volt are incident on a cathode in a photoelectric cell. The maximum energy of emitted photoelectrons is this. The photons of energy 6 are incident. See, the number of electrons will reach. Okay, before that, try this question. This one. According to the Einstein photoelectric equation. Which of the graph is correct? See. Rest of you write your answer in chat box fast. D. Rest of you write your answer fast. Rest of you write your answer fast. B. Is not the correct option. D is the correct answer. Fine. The question was very easy. No. Try this question. Photons with the energy 5 electron volt. Just a minute. Now, these are the graphs. Just remember. As I told you the equation, y k max equals to h nu minus h nu naught. So we can replace k max by ev naught h nu minus h nu naught. And if we move in the denominator, h nu over e minus h nu naught over e. Just remember, if we compare with mx plus c, so if we plot the graph between stopping potential and the frequency of incident radiation, so this stopping potential treat as y-axis and this frequency is treat as x. So this is intercept and this is the slope. So slope equals to tan theta, this is h over e, and h nu naught is the intercept. So it would be a straight line. Fine. So slope of the graph between stopping potential and nu naught, that is nu is this kind of graph, you will get it. Fine. So this is known as intercept. So C equals to minus h nu over e, and tan theta, that is slope, equals to h over e. Now, likewise, if we plot the graph between stopping potential and the wavelength, again, we will use the same equation and you will get this relation. So in this, slope equals to, sorry, so SC over this, if this is slope, fine. So tan theta equals to SC over E, and intercept equals to minus SC over lambda naught E. So lambda naught is the threshold wavelength. And if we increase, what is the relation between wavelength and frequency, Alan? They are inversely proportional. Fine. If we increase the frequency, the wavelength decreases. Is it okay with everyone?
Yes, sir.
Now try this question. Fast. Fast. Write your answer in chat box, everyone. Fast. D. Alan. Rest of you write your answer in chat box fast. Which formula we have to use it, Alan, by the way?
So the work done formula.
The work done formula?
Yes, sir. Like EV by E.
K max equals to H nu minus work function. D. Anipa. Now, see in photoelectric cell, the photons with the energy of the photon is given. That is, we can write K max equals to E minus work function. So what is 5 electron volt is given. The work function is also given, and the maximum energy of the emitted means kinetic energy is given. It is 2. Now work function equals to phi naught equals to 5 minus 3, that is 3 volts. 3 electron. Then further what we have to do it, Alan?
Then you subtract 3 from 6.
Sorry,
So you subtract 3 from 6.
subtract. Now work function is 3 electron volt. Now further work function we have to calculate work function. This is work function. Just a minute. I just come in a minute. Sorry, everyone. Now, further we have what we have to do it. The stopping potential we have to calculate. That is now the photons with the energy 5 electron volt incident on a cathode C. The maximum energy of the emitted photoelectrons 2 electron volt when the photons of energy 6 electron volt are incident on C. The number of photoelectrons will reach the anode A if the stopping potential A is relative to this. So this is equals to V cathode minus V anode, and we have to find out we have to calculate V anode with respect to this. So work function equals to work done. This is equals to V anode minus V cathode. That is equals to minus 3 electron volt. The stopping potential we have to calculate it. Stopping potential. So work function equals to, let me think. For now, please hold this question. Now, Planck's quantum theory. According to Planck's quantum theory, the light is made up of discrete packets of energy that is known as quanta, and one quantum of light is called photon. Now, energy of a photon is h nu, that is equal to hc over lambda. This is frequency. So frequency is speed of light over wavelength of the light. Now, h is a Planck constant at 6.63 10 to the minus 34 joule. Momentum of the photon is h, energy over c. Just remember this formula. Fine. Remember this formula. So Sc equals to h nu over c, Sc over lambda. Now write the formulas in your notebook first. Note down. Fast. Done. Now force and the pressure exerted by the incident light. If it is a metal surface and as the light falls on it, so it exerts the force or pressure on the surface. So the force and the pressure exerted on a perfectly reflecting surface. So let it be a photon strikes this metal surface and it reflects back. Fine. Let it be its initial momentum h over lambda. So the momentum of photon is h over lambda, and it reflects with the same momentum in the opposite direction. So if we can take it right as positive and left as negative, that is incident photon, this is reflecting photon. Now change in momentum of the surface is 2 n h over lambda. N is the number of photons. Change in momentum means if we try to find out the change in momentum, what is change in momentum? P final minus P initial. Fine. So change in momentum is, if we take it this direction is negative, h over lambda minus h over lambda, so it will come out 2h over lambda. Fine. So let it be n number of photons. If you multiply, we have to multiply by capital N. Now, so change in momentum of the surface is just opposite of is 2 nh over lambda. Now further, now force on the surface, force is rate change of momentum delta P by delta T. So just divide this by delta T. This is the formula. Note down in your notebook. F equals to delta P over delta T. So what is change in momentum? 2 nh over lambda. and divide by T. So this is the formula for the force on the surface. And capital N is number of photons per unit time. Capital N by T. Now fast. Done. Shall I move?
1 minute, sir.
Done.
Yes, sir. Okay.
This is the power formula. NSC over lambda. Write all the formulas. Power is work done upon time. That is energy upon time. So energy of a photon over time. Write this. Pressure on the surface, force upon area. This is the formula. P is the power. Fine, don't get confused. This P is power. So 2P over C times A is the area. And power over area is known as intensity. Done. Special case, this is a case of perfectly reflecting surface. Fine. If photon strikes at an angle some phi, so this is the formula for the force perfectly reflecting. So as the photon strikes the surface and it rebounds at the same angle. So this is phi is the angle. Make an angle with the horizontal. So force formula is 2P over C cos phi. And pressure is force over area. These are the formulas. Note down. Done.
1 minute, sir. Done, sir.
Perfectly absorbing. So as the incident, as a photon strike this surface, so the photon will be absorbed by the surface. So the momentum of the photon h lambda and P2 will be 0. So change in momentum will be just half of the momentum that we have seen earlier. Change in pressure is n lambda and h over lambda. In perfectly reflecting, it was 2. It is 2 ns over lambda. Power is nsc over lambda. Fine. And force is power over c. Just half of the reflecting surface. That's it. This is power. And the pressure is force over area, P over A times C. And P over area, power over area is intensity. In reflecting, it was 2 times. Done.
So this is for what?
This is for perfectly absorbing. Done.
1 minute. Done, sir.
Okay. I left one of the question. No, it was the question. So the work function is might. Just a minute. Fine. So the work function is 3 electron volt, and this work function from we have to calculate from, I think, anode to cathode. So work function equals to, we have to calculate the potential. So potential E times potential, that is equals to 3 electron volt, and this potential is this change in potential basically. So change in potential is cathode minus anode equals to 3 over this electron volts. Fine. So electron, if we change it, you will get 3 volt, but this is cathode minus anode. So anode minus cathode equals to minus 3 volt. Deal of. Now try this question. A source S1 is produced 10 to the power 15 electrons per second of wavelength. This lambda is given. Another source S2 is producing this much of per second length. Then the power is fast. Use the formula. Fast. Try this question. 2 minutes and write your answer in chat box. Everyone, fast. Please write the answer in chat box. Okay. Power is and SC over lambda. This is the relation. So power inversely proportional to lambda. What is n number of electrons? So P1 over P2 equals to lambda 2 over lambda 1. What is lambda 2? Lambda 2 is, sorry. Directly proportional to n over lambda. So n1 over n, lambda 2 over n2. So what is n1? 10 to the power 15. Fine. And n2 is 10 to the power 15, approximately equal. And 5,000 Armstrong over 51,000 Armstrong. And this is 1.02. Correct. Now solve it. How much will you get if you solve? If you divide 5,000 over 1,500 Armstrong into 1.02. Alan, if you multiply, how much will you get? 5,000 over this? 51. Solve it. Just a minute.
Sir, 51 should be up, sir.
51.
It should be in numerator and 50 should be in denominator.
Oh, sorry. 51. 5,000. Is it correct this time? I think this one is
Yes,
correct.
sir.
Now solve it. 51 510 divided by 51 divided by 50. Okay, equals to 1. 1 is the answer. Answer is 1. Okay. Is it clear to everyone? Now try this question. Before that, try this question. A radio transmitter operates at a frequency of this and a power of this, the number of photons. Very easy question. And write your answer in chat box, everyone. Done. Alan,
Yes, I'm still doing it.
okay, which formula we have to use it? Mamuna, Saifullah.
P equals to NHC by lambda.
P equals to NH C over lambda. Now, what is N? We have to calculate, power is given. What is frequency? Frequency is, sorry, C equals to frequency times lambda, and frequency equals to C over lambda. So we can replace NH nu. We have to calculate N. H is given. So P over H nu. Fast, everyone. What is power? Power is given 10 to the 3, and sorry, this is H. What is frequency? 10 to the 3. These two will cancel out. Now, what is the answer? Fast, write your option in chat box. Everyone, please write your option in chat box. Everyone, please. Everyone, please write your option in chat box. Alan, what happened to you this time?
So I'm sending it then.
Mamul, Saifullah, Mamuna, Aksha, Farhat, Mamuna, Hanifa. Am I audible to everyone?
Yes, sir.
Now, what is the answer? A is the answer. Fine. If you solve it, you will get 1.72 10 raised to the power 31. Now, dual ratio of radiation. Light shows dual nature of, sorry, light shows two nature, particle nature and wave nature. Likewise, the matter waves means if you throw an object according to the de Broglie, a moving particle shows the wave nature as well, for irrespective of the charge. Let it be if you throw an object, it also exhibits wave character. So the wavelength associated with the particle, with the moving particle, is known as de Broglie wavelength, and the wave generated by that particle is known as the waves generated by that particle known as matter waves. Fine. So de Broglie wavelength equals to lambda equals to h over p. P is the momentum of the particle, v is the velocity, m is the mass. Remember this formula. So the relation is inversely proportional. So lambda is inversely proportional to momentum. Now, according to Planck's quantum theory, energy of a photon is h nu and nu is sc by lambda. And according to Einstein theory, the energy is E mc square. If you equate the two equations, lambda will come out h over mc. Mc is the momentum of the photon. So h over p. P is the momentum. First question, very easy. The wave nature of electrons was experimentally verified by?
Sir, can you show the formulas, please?
So the waves associated with the moving particles are known as matter waves, and the wavelength associated with those particles known as de Broglie wavelength. Done. Shall I move?
Yes, sir.
Okay, now the wave nature of electrons were experimentally verified by de Broglie. The wave nature. I think D is the correct option. According to me, because Davies and German conducted an experiment in which they show actually de Broglie gave the hypothesis that when the particle is in motion, it also exhibits waves like character, and the waves generated by that particle are known as matter waves, and the wavelength associated with it is de Broglie wavelength. But next time I'll confirm you. So according to me, German or German. These are the two scientists who conducted an experiment in which they show the de Broglie was completely correct. Then the particles in motion, they also exhibit wave-like character. Now try this. Which of the following is correct? Very easy question. Write your answer in chat box. Hey, Maimuna. Momentum versus wavelength. The relation was C. Saifullah. Write your answer in chat box fast. P is inversely proportional to wavelength. Alan, write your answer. Everyone, please write your answer in chat box. Speed up. Alan, A. It's not directly proportional. It's inversely proportional. B. Now de Broglie wavelength. This is the relation. H is the Planck's constant under root 2q. V is the potential. H is Planck's constant. Q is charge. Is potential. And M is the mass of the particle. So de Broglie wavelength for an electron is the formula is 12.27 under root V. For proton is 0.286. Fine. For deuteron is 0.02 angstrom. These, remember, write fast, and this relation as well. Very important. Fast, everyone, please. Done. Now try this question. The de Broglie wavelength of an electron moving with kinetic energy. Of an electron moving with kinetic energy. Lambda we have to calculate. And just a minute. Look, we can also write this formula in this way. Look, H equals to under root 2 kinetic energy M. Fine. This formula we can use it. Done. Now try this question. Kinetic energy is given. We have to calculate the de Broglie wavelength. So lambda equals to H over under root 2m K. Write your answer in chat box, everyone, fast. Fast, please, everyone. What is the mass of electron? What is kinetic energy? What is the answer? A. Rest of you, please write the answer. A. Saifullah, write your answer. A. Farhat, A. I'm not doing the calculations. Fine. A. Okay. Fine. So if you solve it, you'll get the answer. Now try this question. The de Broglie wavelength corresponding to the particle of mass m and velocity v has wavelength associated with it. Fast. What is the answer of this question? Fast, everyone. The de Broglie wavelength corresponding to a particle of mass m and velocity v has wavelength associated with it. So lambda equals to h over momentum. What is momentum? Mass times this. So A. Okay. Now try this question fast. A proton and alpha particle are accelerated from the rest to the same energy, the de Broglie wavelength. Fast, everyone. Fast. This formula we have to use it. Alan, write your answer in chat box. Try. Alan, write your answer, please. Everyone, write your answer in chat box. Okay. Look how to do a proton and alpha particle. So lambda 1 over lambda 2 equals to, we can write directly, energies are same, the mass of this is alpha particle. So inversely proportional to mass. So mass of alpha particle over mass of proton. Mass of alpha particles 4 times of proton. 2 over 1. So the ratio is 2:2. Is it clear? Is it clear?
Yes.
Yes. Now, what is de Broglie wavelength? Anyone? What is de Broglie wavelength? Alan, what is de Broglie wavelength? Alan, am I audible to you?
Yes, sir.
What is de Broglie wavelength? What is the formula for it? Lambda equals to h over p. Okay. What is Einstein equation? Saifullah. What is Einstein equation?
E equals to mc square.
No, Einstein equation of photoelectric. K equals to, that's why I told you should note down your notebook. K
E equals to E minus
work
work
function.
function.
Okay. What is saturation current, Mamuna? What is saturation current? Anyone?
What's the
Maximum
maximum
current.
current?
Okay. Do you have any doubt? Alan, Mamuna, rest of you.
So
No, sir.
Does anyone have doubt?